I'm Josh Cooper, CEO of CNC Endless, and my co-founder here, Sam, is standing behind me. And we're a startup company out of Raleigh, North Carolina that has developed portable, deployable CNC machines built for the field and maintenance and repair. Primarily went commercially and have been selling to steel fabricators, equipment repairmen, oil and gas industries, automotive. And we recently secured a phase 1 SBIR grant in the summer of this year with works through the Air Force. And the idea is to try to build more attachments and expand the capability of the current CNC product that we have today. Currently still seeking TPOC and support for the phase 2 of that grant, specifically from the Air Force and related branches. And today we're going to be walking through kind of what this machine can do today and what our future is as far as adapting other attachments for this Mach 1 product, which is the name of the product that we have. So with that, just want to give you some quick pictures here of what this machine can do and show you, since we can't actually do any cutting today inside, but show you kind of what you can expect from this machine. So it's a 25-pound unit that pretty much sets up on steel. As you can see here, it can cut or it can mount directly using an electromagnet. So it'll mount to pipe, it'll mount upside down if you wanted to. It'll mount to the side of a beam, pretty much any surface that you can think of, including having suction mounting capabilities as well with the vacuum base. And what we're using today with the current capability is torch cutting. So oxy-fuel cutting is a great way to cut steel out in the field for all sorts of different things like chip repair, doing beams, putting penetrations in, doing braking and decommissioning of equipment, as well as installing equipment out in the field. And what our machine is replacing is the need to have a skilled tradesperson basically guiding a torch by hand, trying to make precision cuts out in the field. Doing circles is really hard. It's hard to draw a circle on a piece of paper. Trying to cut one with a torch and flame flying back in your face is a nightmare. So what this machine really does is lets the fabricators come into a space and do things like cut through 7-inch thick steel with high quality, which is not something that's typically capable out in the field. So you can see here we've got both an oxy-fuel attachment, kind of just as an example here, and that's the torch that's using oxygen and acetylene to burn through steel. Really great for thicker materials. And then we've got a plasma cutting attachment, and we'll show this interchanging system in a second here. And the plasma cutting attachment is great for all sorts of thinner gauge material, cutting through aluminum, stainless steel as well. And the idea is that we're going to keep building upon the different attachment systems that we have so we can do things like laser cutting and water jet cutting, engraving, beveling, welding, and additive manufacturing. Pretty much any tool you can think of that you could put on a portable, deployable CNC machine is what we want to bring to the field, so that when you're out on the job site or you're doing heavy equipment maintenance and repair or civil engineering and structural work, whatever it is that you might be doing, you'll have one machine that packs up into a convenient carrying case and lets you do that with all the other different kinds of tools and attachments that you might need. So I think with that, that's enough of showing kind of some examples of what it looks like with the machine operating here. And these are some of what our commercial customers use it for different pad eyes and bolt holes and all sorts of different shapes and cutouts. And with that, we'll get into the live demo here. So of course, we're inside, so we've got our plasma cutting attachment, which is on the machine right now. Typically, you would put a plasma cutter or an engraver or something on that. But for now, we've just got a marker so we can show you how the software works and very clearly create some designs, some patterns, show how easy it is to program this thing, and show that it's a modular capability. It's also kind of quick form factor kind of thing. We'll do 25. It's a 25-pound unit, so you can see there's an electromagnet. You can pick it up, walk around with it, take it out to the job site, you can pop it down on your steel, and then tap the electromagnet button on the back, and it locks itself down into place. And then we've also got the suction mounting, which similarly will let you mount to different kinds of materials, maybe composite, aluminum, things like that down the road. There's also a convenient carrying case that it comes with, which is pretty important to point out because that's what makes it actually rugged and quickly deployable. So you see there, it opens up. You got your custom foam inserts, and this whole machine just packs right in that case. And we promise a deploy time of less than a minute from the time you get the case out to the job site to actually getting up and cutting. So you really just pull it out, connect to the tablet, and get ready to go. Sam will hold up the tablet here, so we show what we got there. And we got a little pattern loaded already. We'll go through more specifically what the user interface looks like on my screen here, but for now, let's talk about the modular attachment system and how that works. So you see there, we've got the arm, we've got a module on. So Sam's going to show you how we disconnect the arm really quickly. There's just a little thumb screw in the back, and you can take that off and separate your plasma arm. And then there's also the plasma module, which can slide right off the back. And there's a little electrical connector on that, which is what helps interface between the module that you've got plugged in and the machine so it knows what kind of attachment's installed. And this is what it looks like for the oxy-fuel attachment to put that onto the machine. It's the same thing. You put the oxy-fuel module on the back, and then you use your thumb screw to attach the arm. So we'll go ahead and probably put on the plasma arm after he shows real quick putting that on. I'll show from the overhead what this looks like. Overhead cam on there. So pretty much, you can go ahead and mount it. So pretty much what you can do with our two arms is you can get to just about any kind of shape just by changing the motors and the positioning of them. So all we do is we load in our files, then the arms will move around. We also have 2 inches of height control. That's the Z-axis that I'll show here. And so you see there on the screen, I have the capability to lower down about 2.5 inches. And so those are the height range that makes it really handy to do complex things out in the field like sheet piling and all sorts of curved surfaces. So with that, I'm going to go ahead and walk through the user interface real quick and how you would load a program up, which looks like this. So this is our UI here. And this is what your operators and your fabricators will be using out on the job site to actually operate this machine. The whole reason we're called CNCless is because what we try to do is condense the complex programming that you need to operate a traditional CNC platform or robotics platform and turn it into something that a fabricator or someone that's very new to the trade can come in, make shapes, make their designs, load a pattern, and then make beautiful cuts without having to have a ton of experience or training time. So really trying to limit the amount or the burden really on the operators. And on top of that, this is a completely independent machine that doesn't connect to any Wi-Fi or basically doesn't have to connect to your external network. So all this is super independent and local. So you can truly take this thing out into the field and do whatever you need to do independently. For now, we've got a design that we loaded here, basically just from a flash drive. So you can load any 2D CAD file, just like with all the other CNC machines that are likely in your shops. Put it on a flash drive, scale it, load it, tell it what dimensions you've loaded it in, and pop it into the design space here. And this is where you're going to have the ability to add different things like rectangles and circles and squares, different kinds of elements that you might want to cut out in the field. You can also add on to the design you've already loaded from your DXF. So I'll go ahead and delete that. And then you can also change things like the curve compensation, which just means what side you're leading into a cut with. So if you're cutting a hole, you want to pierce with a torch on the inner side of the hole so that you lead out and it leaves you with that nice precision cut on the outer surface of the hole. And for an outer cut, you're going to want to lead in from the outside or lead out from the outside so that it starts on the outside and then comes in. So what you're left with is the nice highly dimensioned pattern that you're looking for. So that just helps with precision and makes it easier to do torch cutting and actually come out with some really pretty parts. So the next thing you do, so it goes basically from left to right. We have design in the bottom left, and then we go to place, then materials and run. So we've already got our design here that we're going to run real quick. We go to place, and when I reset this arm, you can see I'm moving around the screen here. As Sam is moving this pattern around, you can see, or as he's moving the arms around, which are unlocked, you're getting the feedback of where you're actually going to locate this cut or this design on your material. And so he's going to pop it down somewhere on the plate where it's going to fit. We click this target button to indicate that's where the origin point is. And then we could select 2 additional points if we wanted to align this to a known edge. So Sam's moving it now to the edge of this plate. I'm going to select 1 point at the edge of the plate. And then you'll see there as the arm is moving, we're going to align it with the secondary point. So I tap that. Now he can go ahead and move the torch along the path and see that he's actually got this torch and this part rather exactly where he wants it on the material. So you get that very easy user input of, okay, I can see where my design is before I go and cut it. So I'm going to go ahead and click confirm here. I'm going to go to materials, and basically you just select what you're cutting. So this is plasma cutting. Let's say I want to do stainless steel, and it's 3/8 of an inch, and I have a hypertherm plasma cutter that's hooked up to my module, which is going to be doing what the actual plasma cutting is for. So I'm going to click confirm once I get those selected. And then from there, you go to the run process. It's going to run the G code and load it up so that it can go ahead and cut this thing. I click start, and the machine's going to go to that first point that it's going to pierce on. I'm going to go ahead and lower it down manually because we don't have ohmic probing on a marker. It's no electrical continuity there. So I lower it down, and then when I'm ready to go, I just click pierce. And this is going to cut out whatever shape you had, just like a normal plasma cutter would. So we'll go ahead and let this run. I'm actually going to turn up the speed here as well. So you can control the height of the plasma cutter. You got that 2.5 inch height range that you can do here. and then also increase the speeds. And if you were trying to do something like this out in the field, it would be practically impossible to do like an intricate DXF like this. But even doing things like laying out bolt hole patterns, having to lay out slots, which the best way to do a slot in the field right now is to drill 2 holes and then torch cut between them. Having this machine makes it super easy to lay that kind of thing out and then get to cutting and doing the hard part, which is actually guiding the torch by hand. So really what we're trying to get after is the time savings of not having to do layout, not having to do a lot of cleanup when you're a torch cutter that's trying to cut a line and having to do all the grinding and other post-processing. And the idea is with our modular attachment system is that you'd be able to come in and maybe do a plasma with one attachment, you swap it out for the welding attachment, and then you weld right back into place what you just cut out for a service hole or something of that nature for doing repairs. Similarly, with doing things like ship breaking or doing any kind of demolition or deconstruction work, it's very dangerous to have these large beams and different structures out there in the field and trying to have someone cutting those last cuts before, a massive piece of equipment or something might have the potential to fall over. If you have this machine where you can operate with our tablet, which is operable up to 200 feet away, it gives you that safety factor specifically for the braking parts where you don't have to stand right next to the equipment or the thing that you're cutting. And you don't have to worry about getting hit in the face with the sparks and the flames and everything like that. So that's really the big value add here. And we're going to go ahead and continue to let this Air Force signal run here. But also want to show the ability to do designs and create patterns right there on the fly in our designer. Maybe you don't have a DXF pattern. So this might be a longer program to run. So we'll let it run just a little bit more, and then we'll go ahead and show how you might want to program something else up. There you go.
See the lead-ins there.
Oh, good point. So then, yeah, as you can see here, Sam's pointing to where the lead-in compensates. So essentially, you've got the ability to start on, for the inner cuts, you want to start on the inside and lead out into the pattern. And for the outer cut, it'll start from the outside and lead in. So probably got about another minute here before this finishes up. And then you've also, of course, on the right-hand side of the user interface screen, you can see that there's a emergency stop button. There's also a physical latching emergency stop on the back of the machine. So on top of just trying to provide more capability with precision out in the field, really shooting for that safety factor too, so that even the fatigue of having to do torch cutting for a long time, like in the time that I've been sitting here talking, haven't had to actually touch anything. We're just monitoring it rather than having to be very involved with it and focused the whole time. And then I'll also note that we've got the ability to, there's a pause button right here. We've got the ability, if we wanted to, in the middle of a cut, if something we needed to pause it and then rewind and fast forward, we can also do that. And we're just about done cutting this outer profile here, so I'll let it run here, and then we can go show some more design features. But I speed it up too. So you see there, I sped it up to about 290%, so it's going pretty quick now, and you're not really losing much on the precision side doing that. All right, so now that the machine has cut, we can go ahead and unlock the arms, move it out of the way, put down the machine on another piece of material, or maybe you want to just move a piece of material to it, and that's pretty much how you can pretty quickly create pretty complex designs. So I'll go ahead and show here more specifically on the user interface from the designer of how you could load a pattern. Say I wanted to clear this and load, say I wanted to make, commonly for structural parts at least, we can do all these custom kinds of elements if you're doing hide revisions. This is like an example of a triangular gusset. And so you can come in here, we can have these custom shapes for really any process or anything you could think of where you're doing repetitive things over and over. We can make these templates for it where you just come in and you say, I want it to be however many inches wide, that tall. Say I want to change the leg width of it, and I want to make a decent sized radius on there. You can automatically change these, on the fly. And then likewise, you can come in and add bolt hole patterns. Say you wanted to have, 1 1/8 hole here. You can touch and drag to move your shapes around. You can position them more precisely if you want to. You can make rectangular patterns, circular patterns of different things. You can go like this. So that might be a part you want to make, and instead of having to lay this out with a marker and then have it cut it by hand, have that ability to go back to our place function here. We'll go back to the overhead cam. Now it's cleaned up the marker from before. We go back to our place. He moves to the origin point. We click the origin, and then again you'll notice that Sam actually put the machine at an angle. So now we're going to align it to the edge. Again, with those 2 different points along the known reference. Once you've got your material settings set, you don't really have to change anything there. So you can go right back into run, and go from creating a design of a gusset or a prototype that you want to fabricate. Actually, before I do this, I actually want to change my lead out from the outside so we get the right lead in. So change to outside, click done, start, and then lower it down again and click pierce. Yeah, so instead of having to spend time actually laying this out, you can pretty much go in and rapidly create prototypes with torch cutting, structural parts up to 7 inches thick at least with our current attachments, and then hopefully we have a whole range of different attachments you can quick swap between down the road for all the sorts of different handy fabrication processes you might want to have on the job site or out in the field. So we'll show this, and then we'll show one more thing with the point-to-point tracing mode that we have. So go ahead and let this finish out, speed it up. And I'll actually pause this in a second here, and I'll show you the pause and rewind feature. So let's say you wanted to pause in this last straightaway. You can actually pause and then rewind the cut to wherever it picked off. And then say you wanted to offset it to the outside again. We'll go this way. Offset it to the outside, click resume, pierce, and then it picks up right back where it was left off, and you can recover cuts very quickly. So with that, I'll go ahead and have Sam move to point to point. I'll go ahead and show this on here, Sam. Probably just tell him. All right, you can move it. So go to point to point mode here in the designer. And let's say we actually just wanted to do a straight line at the end of this cut. I'll go ahead and unlock the arms here. We can essentially pick points off of where the machine knows that it is in space. So Sam's moved the point down. He'll move the arm or the indicator, the marker, to the point where he wants to start a line from. And I'll do a start point. And then he goes to the end over here. And then let's say we wanted to do another line that way. And then you want to do an arc.
Yeah, sure.
Do a little arc. Select the middle point and the end point.
Close it up. And
then close the shape. And so we've now just made this shape in real time just by clicking points and basically tracing them. And now we can go ahead and run that cut just by going back to the run screen.
You might have to click on it now.
And click start. So we go to the first point, lower it down again so don't forget so we can actually see what this thing's cutting out. Then click pierce, and then I'll go ahead and speed this thing up again too.
And even with the point to points, it doesn't lead in.
Yep. Yeah, and even point to point modes, it'll do the lead in. So we had it do an inside lead in, probably could have stood to do an outside on something like this, but essentially you get a lot of control and for a product that you have operated by fabricators and welders. This gives them the ability to do some precision cutting really quickly and load programs on their own without having to go to a CNC operator or controller right away. So I think that's pretty much all that we wanted to showcase right here. That was the e-stop button that we just clicked. So you can show there it latches, pop it down, and I think that's pretty much it. So I think that's ultimately what we're trying to get at is just, hey, we have this new machine here. We just started this about 2 years ago is when the company started. I've been working with the Air Force for a little bit now and still looking for support for people that might be interested in adapting this product to whatever manufacturing process or inspection or any kind of process that you have out on the field or in a unique job site situation where you don't want to have a full 20 by 20 piece of equipment taking up space, and say you want something you can stow away and deploy when you need it, take it overseas, whatever that may be. So with that, I'm happy to open it up for any questions. I think we're pretty good on time here, so please fire away.
Yeah, Josh, this is Ray. We got a series of questions in chat. I'll go ahead and read them. The first one was actually, I think, answered. It was, is this a prototype or is it available for purchase now? Donna Stacy put a link in there saying it is available for purchase.
I guess that's an important thing to talk about. Yeah, so we sell these machines for $9,750 to any user, so less than 10 grand. So that'll get you one of the attachments. So you can choose the plasma attachment or the oxy-fuel, and of course it'll hook up to your current plasma cutter. And then I can actually go ahead and share. I think I'm still screen sharing, so I can share our website here. That's pretty much the best place to go. You can actually purchase directly from the website. Of course, we're on sam.gov and everything like that too. You can do purchase orders, but on the website here, it'll walk through all the features. Our warranty, we offer a 3-year warranty. Can do, let's see, so I already passed the purchase part. So these are the 3 options. So you buy 1 attachment with the full machine or 2 attachments with the full machine. And that price is with the carrying case, the tablet, all the software, lifetime updates. Doesn't require any subscription or anything like that. That includes shipping and everything. So all in for less than 10 grand and $12,500 if you wanted both attachments. So.
All right. Thanks, Josh. Another question, will you be going to the DoD Maintenance Symposium?
Yes, we will be there. We will be And I believe we'll be right across from the Navy booth. I probably should have the exact booth number up, but yes, we'll be presenting at the DoD Maintenance Symposium.
Okay.
Sweet. You'll make sure you walk over to the Navy booth. We want to talk.
Right on. Hey, that's awesome.
Would a user typically have a few preloaded programs for cuts, or can drawings be created directly on the tablet?
So yeah, typically you're going to want to cut something specific. So we typically do include like a couple of just like example DXF files, but you can load any DXF to the software and it'll, you can load it in and then cut that on the site, or like you saw with the user interface there. If you wanted to do a quick design, like you can go ahead and make that in the designer and make cuts right away. So yeah, you can load DXFs and we can have a couple on the machine just saved locally.
Okay. What's the power source in amps, single phase, three phase?
So single phase, 120 volt. So just simple, you just plug it into the wall.
About 2 amps.
And about 2 amps. I think it's actually less than 2 amps, but yeah, so around that range. And then the following question is sometimes, will it be battery powered? And hopefully if we get funding from the DoD for phase 2 grant, we can have that be part of the scope, is making it fully battery powered, because it does not take a lot of power to operate this thing.
We run it on this battery.
Yeah, we're running it on if you see the camera right now, we're literally just running it on a portable battery source that will last 10 hours.
All right, good to know.
So this is, I'm the one that asked that question. If I can jump in, Ray, on your power. So 2 amps is not a lot. Is that to operate the arm and the motion of it, not the actual power for the plasma cutting? Obviously, the oxyacetylene is coming from the oxyacetylene tank, but so that's a different power source then for plasma?
Yeah, you're right. So that the 120 is our machine. So it'll adapt to whatever plasma cutter you have. Most of them are 240, so it just depends on what cutter you have. And we have this cord that you can see Sam has in the back there. So that just connects our machine to the plasma cutter. I guess here, I'll show this.
So does the machine turn on and off the plasma cutter, or do you have to manually turn that on and off?
Yep. So that cord that Sam plugged into the module on our machine actually interfaces with the controller on the plasma cutter. So all of that's automatic. And similarly for oxy-fuel, we have a manifold where you plug in the oxygen and fuel source, of propane, acetylene, propylene, whatever. And there's 2 valves for preheat flame, but the cutting jet itself is actuated electronically. So you don't have to go and turn on another valve every time you want to pierce, essentially.
Okay. So I saw some of your, sorry, I'm kind of jumping in a whole bunch of questions. I saw you working outside. Is this ruggedized enough to work in rain, snow, sandy desert, wind, or just really nice weather?
So we've operated in the rain. There's seals on most of the most of the joints, and there's the most important part is that hydraulic seal on the main arm. That's where it would actually not be great. We wouldn't recommend operating in heavy rain right now. Like that's one of those things where with the scope of the phase 2 grant, hopefully we can allocate some of that R&D to getting this thing to be like a shockproof, waterproof, dust resistant to some kind of like actual rating that's significant. But this thing does last out in the field, and we've had constructors drop it from 6 feet on a concrete when it's on a beam, and it's completely fine. Wouldn't recommend it, but they do.
Okay, thank you very much.
Yep, thank you.
Okay, thanks, man. Is there a specifications document that can be shared?
Yes, that's actually on our website. If we go, I'll show on Google, and we can forward some of this information again after the demo here. But if you go down here to specifications,
okay,
there's some specs there, and then the complete specs are found in the brochure. Click here, and then that's our brochure here, so it has everything, and then also the specifications for each individual attachment, or the base machine, the case, the tablet, all that good stuff. So
okay.
Yeah.
Is there a plan for an end mill head? So
the end mill head's pretty much impossible for this configuration, we think, just because, or at least for like a large one, because you've got 2 arms that are out here, all the vibrations, and even the Z-force you would need for that height control to get something that has any kind of substantial pressure to do what an end mill would need to do. It's going to be out of the scope for what this configuration would be. I think as our company develops more products, like I said, we've only been doing this for a little while now. We're planning to develop a whole slew of different products. So if that was something that was really important, then that would probably fall into a whole different design, specification, and we would just design something else and develop that end to end.
So doing any kind of milling on an arm like this is really hard. Like even those big automotive robots they use in like car factories, they can't even do machining on metal. They can do it in like foam and wood, but you have to have a lot of stiffness and like vibration resistance to do any kind of machining without having chatter everywhere.
Yep, chatter is a big deal. Yeah, and just kind of putting it out there too, like the company right now is like, we do everything from design of the mechanical side to the electrical to software. Like we do all of our manufacturing in-house here in Raleigh, North Carolina. We design the parts and then we literally put them together here. So everything you see is designed by us, and that means that we can be very quick with developing prototypes and making good software updates and designs. So that's kind of the benefit of being a young company.
Okay. I'm only going to ask a couple more questions. There's more, but some of them are actually answered in the chat. There's a couple questions on security, data security specifically. You talk about using a flash drive, which many people in DoD are not authorized to use. So have you thought about cybersecurity and the transfer of the data?
So because our machine doesn't connect to Wi-Fi right now, essentially like the answer is the flash drive for now. And frankly, like from I'm interested to see how other machinery, like pieces of equipment, handle this, because from our experience going to bases, like everyone that has like a CNC machine that they're using, they don't connect those to the network either. They seem to just upload the programs to flash drives and then do it offline that way. So that's how we were planning on getting the file transfer to work. But as far as like, if there's another way, like we're here hoping to get some more information on how we could interconnect it and have if that's something that's desirable, to be able to do the file transfer and sharing. I'll let Sam speak a little bit more on that.
Yeah, so we don't have any customers that do this right now, but if you wanted to, like you can like SCP a file over, like kind of SSH style file sharing, and not have to have a flash drive. Like we can share like you can put your SSH key on here if you wanted to send files securely that way. So that's an alternative to the flash drive.
Okay, it looks like you thought of it. And I would say anybody out there, if you have a solution to help them with, by all means, I'm sure they'll be open to talking to you. And there was another one on here. Oh, calibration. How often does the machine need to be calibrated? Can it be calibrated by the users, or does it need to be sent back to you guys?
So our machine has absolute encoders in it, and those are constantly plugged. They're always plugged in to a battery that runs inside. So as long as you turn your machine on once every 4 years, it stays in calibration. We have had a time or two that we've had someone that wanted to recalibrate. Maybe it's because it got dropped or something like that happened where it was off by just like half a degree, which does make a difference at times. So we have a software feature where you can recalibrate it at your leisure, essentially. So I hope that answers the question. But no, you don't have to do recalibration. You shouldn't have to do it. And if you did, you can do it remotely, or yourself, rather. Thank you very much. And yeah, on our website too, like we have scheduling, like you can book a demo just like this one. If you wanted to share this with your team and wanted to talk more about a specific application, you just click book a demo and then you pick a time to meet with us. And we basically do this and we talk specifically with you. So we'd love to invite you to book a demo if you are interested in talking about this further. And yeah, thank you very much for your attention. And we really appreciate this opportunity. So thank you to JTech for letting us come out here and show you all what we have.